Hey everyone, welcome back to the channel. Today we're diving into something that's been absolutely blowing up in the AI developer community this month. It's called loop engineering, and it represents the biggest paradigm shift in how we work with AI since prompt engineering became a thing. You've probably heard the quote from Boris Cherny, the head of Claude Code at Anthropic. He said, and I quote, "I don't prompt Claude anymore. I have loops running. My job is to write loops." Peter Steinberger's post about this got over 6 million views on X in under 24 hours. Addy Osmani from Google wrote a comprehensive essay on it. This is the topic right now. So in this video, I'm going to break down exactly what loop engineering is, why it matters, and how you can start using it today. Let's get into it. So let's start with what we've all been doing for the past 2 years: prompt engineering. The workflow is simple, right? You sit down, you carefully craft a prompt, you send it to the AI, you read the output, and then you do it again and again and again. You're the human in the middle of every single interaction. Every turn requires your input. You are the bottleneck. And here's the fundamental problem: your output quality is completely dependent on your prompt quality. If you write a bad prompt, you get bad output. There's no self correction happening. The AI doesn't look at its own work and say, that's wrong, let me try again. This is the single shot paradigm. And for a while, it worked great. We got really good at crafting prompts. We learned all the tricks: chain of thought, few short examples, system prompts. But there's a ceiling to this approach, and we've hit it. Now, here's where it gets exciting. Loop engineering flips the entire model. Instead of you prompting the AI every single turn, you design a loop, a cycle where the AI plans what to do, executes it, evaluates its own output, and refines its approach. Then it goes around again and again until the job is done. The key insight here is the AI prompts itself. You're not in the middle anymore. You design the loop, you set the goal, and you let the system iterate. Think about it. When Claude Code fixes a bug, it doesn't just try once. It reads your code, tries a fix, runs the tests, sees what failed, adjusts, and tries again. That loop is the intelligence. This is the fundamental shift. Your job moves from writing the perfect prompt to designing the perfect loop. This whole thing exploded in the first 2 weeks of June 2026. Let me tell you the story. Boris Cherny, the guy who literally created Claude Code at Anthropic, went on stage at the WorkOS Acquired Unplugged event and said, "I don't prompt Claude anymore. I have loops running. They're the ones prompting Claude. My job is to write loops." Let that sink in. The creator of one of the most powerful AI coding tools in the world doesn't prompt it anymore. Then Peter Steinberger, the creator of OpenClaw, which became the most starred new repo on GitHub, posted 12 words that broke the internet. You shouldn't be prompting coding agents anymore. You should be designing loops that prompt your agents. That post got over 6.5 million views in under 24 hours. And then Addy Osmani from Google published the essay that gave it a name: Loop Engineering. That's when everyone went, "Oh, this isn't just a tip, this is a paradigm shift." Boris described his own evolution in 3 stages. And honestly, this maps to where most of us are right now. Stage 1: autocomplete. This is 2023 into 2024. You're writing code by hand, and the AI is helping with suggestions. Copilot, Tab9, that kind of thing. The AI is a tool you hold line by line. Stage 2: parallel sessions. Early 2025. Now you've got 5 to 10 Claude Code sessions running at the same time, and you're prompting each one manually. You're more productive, but you are still the bottleneck. You're the one in the loop. Stage 3: loops. This is 2026, and this is where it gets wild. Boris now has agents that read his GitHub, his Slack, his Twitter, and they decide what to build next. He doesn't prompt them, they prompt themselves. And here's the receipts. In December 2025, 100% of his contributions to Claude Code were written by Claude Code, 259 pull requests. He deleted his IDE in November 2025 and hasn't opened it since. That's not a productivity hack. That's a completely different way of building software. So what actually makes up a loop? Addy Osmani mapped out 5 building blocks, and what's incredible is both Claude Code and OpenAI Codex have converged on almost identical primitives. First, the goal. This is the stopping condition. You say all tests pass and lint is clean, and the loop runs until that's verified true. In Claude Code, this is the slash goal command. Second, the scheduler. This is how the loop fires. It could be a cron job, a slash loop command with an interval, GitHub actions, or a manual trigger. Boris literally runs some of his loops on cron. Third, and this is crucial, the verifier. A separate model checks whether the goal is met. The agent that wrote the code does not grade its own homework. This is a structural insight, not a model limitation. Fourth, memory. This is Claude.md, a markdown file that persists learnings across sessions. When an agent makes a mistake, the correction goes into Claude.md so every future session knows about it. And fifth, isolation. Git work trees for parallel subagents. Without isolation, multiple agents editing the same files cause merge disasters. These 5 blocks are the anatomy of every production loop. Let me show you what this actually looks like in practice. This is Boris Cherny's own example. You type one command into Claude Code /loop babysit all my PR, autofix build issues. When comments come in, use a worktree agent to fix them. That's it. That's the entire instruction. And then the loop runs autonomously. It monitors your open pull requests. When a build fails, it detects it. It spawns a separate worktree agent. That's the isolation piece. To implement the fix. Then a separate verifier model confirms the fix actually works. You didn't write the specific steps. You didn't debug the failing test. You didn't review the fix. You wrote the intent and the stopping behavior, and the loop handled everything else. This is running while you sleep, while you're in meetings, while you're thinking about what to build next. The loop is handling the execution. Let's put these two paradigms side by side so you can really see the difference. Prompt engineering is single shot. You send a prompt, you get a response. Loop engineering is iterative self-correction. The AI tries, evaluates, and tries again. In prompt engineering, you are in every turn. In loop engineering, you set the goal and the AI executes autonomously. Here's a big one. In prompt engineering, your output quality equals your prompt quality. If you're bad at prompting, you get bad results. In loop engineering, quality equals your loop design. And a well-designed loop can compensate for imperfect inputs because it self-corrects. Prompt engineering is typically one agent, one task. Loop engineering, multi-agent, parallel work with isolation via work trees. And memory. In prompt engineering, you manually load context every session. In loop engineering, Claude.md persists learnings across runs. The agent literally learns from its mistakes. The shift is clear, and it's happening right now. Now I'm going to keep it real with you. Loop engineering is incredibly powerful, but it comes with a cost, literally. Token costs in agentic loops compound faster than almost anyone expects. We're talking 10 times multipliers compared to single-shot prompting. Every iteration of the loop consumes tokens. The verifier consumes tokens. The sub-agents consume tokens. In one documented experiment, a single loop ran for 25 hours unattended and burned through 13 million tokens. It also produced 30,000 lines of code, so there was massive output. But you need to be aware of the economics. Here's the critical warning. An unattended loop without a verifier is what they call a money furnace. If the loop can't tell when it's done, it just keeps running and burning tokens. So always set budget guards, always have a verifier, and always have a clear stopping condition. Loop engineering isn't about setting it and forgetting it. It's about designing the right constraints. All right. So how do you actually get started with this? Here are 4 concrete steps you can take today. Step 1. Write a Claude.md file. This is the single most important thing you can do. Document your project context, your coding patterns, your rules. This becomes your loop's persistent memory. Every session reads it. Every mistake gets corrected here. Step 2. Use the /goal command. Set a verifiable stopping condition. All tests pass and lint is clean. That's a good goal. Make it better. That's a terrible goal because the verifier can't check it. Be specific and measurable. Step 3. Start small. Don't try to automate your entire workflow on day one. Start with /loop on a single pull request. Watch how it works. Build confidence. Understand the token economics. Step 4. Always add verifiers. This is non-negotiable. Never let an agent grade its own work. Use a separate, often smaller and faster model specifically for checking whether the goal condition is met. These 4 steps will get you from prompt engineering to loop engineering. Start today. So let's bring it all together. For 2 years, we've been getting better and better at prompting, and that was the right thing to do. But the paradigm has shifted. The leverage point has moved. It's no longer about crafting the perfect prompt. It's about designing the loop that does the prompting for you. Boris Cherny isn't saying engineers are obsolete. He's saying the opposite. Great engineers matter more than ever. Someone still has to decide what to build, talk to customers, coordinate teams. But the execution, that's what loops are for. The job didn't vanish. It moved up an altitude from writing the code to writing the thing that writes the code. So stop prompting, start designing loops. If you learned something new today, smash that like button. It genuinely helps this channel grow. Subscribe if you haven't, and I'll see you next week with another deep dive. Peace.